minimize this again here. High floating controls. All right. So you guys are going to get, a file like this, and I'll also provide the cover, which is just, again, it's very simple cover. And this will be made out of acrylic. So you'll get to use the laser cutters. If you're already trained on laser cutters, no problem. You get to kind of skip that part of the training and just make this part yourself. Even if you're trained on the Bridgeport mill, I still like you to go through it with me, because we're going to be using it a little bit differently than how you guys typically use the Bridgeport mill. So we're going to be doing some advanced features on the Bridgeport, and so I want you to make sure you understand how to do that. But you guys are going to get a blank one like this. And so one thing I do want you to do is to customize the back part of the panel. And again, it's up to you to do whatever you want. But just really quick here, I'm going to quickly just give a quick demo on how to, again, doesn't have to be, this hexagon honeycomb pattern like I made. It could be, something really quite simple, like, let's see here, if I just do like, something like this, what's the offset? This by 0.125, let's offset, this by 0.125, and then I come in and I extrude these. So I know you robotics students are disappointed by my slow CADing skills. And then of course, when we think about CNC machines, CNC machines can't make sharp internal corners, right? There's no end mill that's small enough to make a perfect point like that. So if I come in and I put a fillet in all these corners, all right. So bring it down. See if I can get in there. Yep. Oops. I missed one here. Gotta change my view here. So, all right. So there's an example of how you could quickly customize the back of your thing if you wanted to. But again, get as fancy as you want. It's fine. And you guys can just customize. I do want you to customize, and I want them to be through hole parts, or through all the way through the back, just to make it light and kind of help to get the RFID part through. But anyway, that's kind of what I'm expecting you guys to be able to do: customize this back and then design the toolpath. So part of that is because I don't want you guys just to follow this video, go back and watch this video and do exactly what I did. I don't want you to just copy each other's. I want you to actually, design at least a couple of your own toolpaths, without just copying. But let's go through a little bit and talk about the toolpath design. So I'll go ahead and use this one as an example. And let's see, I gotta, yeah, we can use this as an example. All right, so if I go over to the CAM side of things, right now this is blank and empty. To get started, if you go to the CAM tab, the first part and one of the most important parts is to do your setup. And this, you can think of setup as like setting up like your stock of, like, you're going to, when you go to cut this out of the machine, it's going to be a piece of metal, right? And you're going to start with a piece of metal, and then you're going to cut it with a CNC, like you're going to sculpt it into this final design. So when we do the setup, it's telling the machine not only where your origin is, but also kind of the thickness and the length and width of your stock material. So you might see my computer do something kind of weird. That's just one of the joys of working with Autodesk Inventor, is sometimes you have some weird quirks with it, but you have to figure those out. So I'll show you that in a second here. But we're starting off here. You're going to set your work coordinate system. And this is really important. The way you always want to set your work coordinate system up in the top left-hand corner, the back left-hand corner of your part. And so I'm going to cut our part in this orientation, where this is the back left corner of the machine. And then so I'm going to set it up here. And I want to set it, in this case, I want to set it off my stock and not off of a point on my model. The reason you set it usually in the back, well, you have to set it on the left because that's the way the machine works. Where at least not, well, it's the way machines typically work. They follow the right hand rule. If you stick your right hand out in front of you with your palm up, and have your thumb sticking out, with the direction of your thumb is positive X, the direction of your fingers away from you is positive Y, and if you curl your fingers up, that's positive Z. So the same thing works with the machine. And so that's why you set it up to the left side. The reason you set it up in the back is because if you're setting your part up on a vise, that jaw of the vise doesn't move, the back jaw. The front jaw moves when you open and close the vise, the back jaw doesn't. So then you have a really like a fixed position. So you can even set up a vise stop. And so that, you know, if you're cutting out multiple of these, you can just take you can cut your stuff, take it out, and then put another one in, and then rerun your tool paths again without having to re-zero everything sometimes. So that's why it's always the back left corner. So the way I'm going to do that is I'm going to change from model orientation, because obviously my stuff is not in that left right hand rule. I'm going to say X and Y axis. And then for some reason, yours should pop up with little dots all around. Mine's not. If I click that again, then it comes up with all the dots, and I'm going to select the top left corner there. And now obviously Y is in the wrong direction, X is in the wrong. So I'm going to say select X axis, and I'm going to select a horizontal line. And now Y is in the right axis, but in the wrong direction. So I'll select Y, and that one, it popped up. Okay, it came up. Sometimes you have to flip X or Y, and you want Z, Z to be going up towards the sky. So this one actually is in the right one. My computer didn't glitch out this time. Sometimes it like all of a sudden the coordinate system will like jump over to this side or something like that, and I got to reselect it. But it didn't this time, so that's good. So after I get that, then I go over to stock, and this is where I would define the piece of stock I'm setting up. And I'll give you I'll give you a piece of stock that you can measure and define. But basically, I'm going to make the Y is going to be, let's see if I do, yeah, additional stock to all sides, top and bottom. So the top is just going to be, let's see, I want that, let's see, I want to do all sides. Oh, this is what I want to do. So I can change the mode. I can say like a fixed size box is what I want to do actually. And so this one, if I just had a piece, I could just measure it and then put in all the dimensions, and then I'm done. And then I can, I can change the position of the model, and I'm going to do that for Z, and you'll see why in a second. So my Y depth, I'm going to make 2.75, and that's actually the piece of stock I'm going to give you. The X, I'll keep it at 4.5 for now. I might make it a little shorter. And then for Z, it's going to be like 0.25. So 1/4 inch thick piece of aluminum. And so I actually don't want it to be in the center. And the reason being is because I got to clamp this part. And that's one of the challenges of machining in general, and also with CNC machining is, right, we have to think of how we're going to hold the workpiece. If I'm holding this whole piece from the top almost to the bottom, and then I try to like cut out this profile, I'm going to run into the vise, and I'm going to ruin my vise and my part. So I don't want to do that. So this one I'm going to say, let's say offset set from Z plus, and I'm going to put just like 0.01. And so, and I can even, it doesn't have to be the nearest thing here, but nearest 1/2 inch. So I'm just gonna, put this at, a 100th of an inch below the surface of the part. And that gives me enough space to be able to surface or face off this part. But it still leaves me a lot of room down here to actually hold on to the stock material. And then I can cut out this whole part without, removing it from the vise or doing anything, and not be afraid of hitting the vise itself. Inside the Tontai CNC, there's they're called talon grips on the vise, and they're kind of they're kind of serrated, like a dovetail type clamp that really actually digs into the material on this bottom part here. And it's only, I think, I don't know, 400ths or something off the top of the vise. So it doesn't need very much material to grip onto it, and it holds it really well. So anyway, once I've done that, I can click OK. Let's see. Let's not ignore that. So for some reason, I don't know if I clicked something here, but my model is there. So I don't know. Normally it's auto selected. I might have clicked off it. So anyway, I'll click that, and that's my setup. So if I ever need to check it, I can go back here and do this. You're going to have a setup for basically every time you need to, take this part off the vise and change its orientation or do something like that. You're going to have a different setup. So if you take this off and flip it to the other side to machine the backside of this this part, then you gotta have another setup. So keep that in mind. So the next part I would do is let's do a toolpath now. So first one I would do is a facing toolpath. These are pretty simple, straightforward. So if I click on face, it's going to come up with tool. Doesn't have a tool selected. So I did send out, and if you didn't get it, I can send it out to you or to your program lead. But I sent a tool library for the CNC, and so you don't need to create tools for the CNC. The tools are already there. You can change tools, like say for drill. Drill is one that obviously changes often depending on the size of hole you need. So those are expected to change. I would also not, go by this and say, oh, okay, tool number 12 has a number 11 drill in it, so I'm good. That's what I needed. Always check your drills in the machine physically before using those tools, or before running that toolpath, because some of you might have changed it and it doesn't automatically update in the tool library. However, I don't want anybody changing out all these tools. So there are 21 tools inside the CNC. If you needed to say, you're like, oh, I need a different tool that's not in here, and I don't need a reamer, so I'm gonna take out tool 21 and put in a different tool. Then really it needs to be me that makes that change. So we do have a couple extra, or either that, or no, actually it just needs to be me that makes the change. That's one of the main things that can go wrong with this machine, is if we don't set the tool heights properly, then your machine will go to wherever it's set, and it could crash your tool, the machine. So I'm going to teach you how to set tool heights in case you do need to change out a drill or something, but I really don't want this tool library getting too mixed up. So it's better if I manage the tool library, and then I can send out updates if we change out tools. I can send out updates to everybody. But it's pretty easy, guys. Just you can let's see, if you right click on my library, you can say import library, and then just find that file that I sent you. And then you can import it, and it'll show up just like this, VCS. You can change the name if you want, but these are the tools in the machine. So that's a nice thing is we have an auto tool changer on the machine itself. So any of these tools that are in here, you can program and run all those tool paths, and the machine will automatically change the tool and keep going, and then change to the next tool and then keep going. It's pretty nice. I mean, that's that's a nice feature to have. All right, hold on a second. I'm just, since I can't see any of you guys, show video panel. Yeah, okay, now I can see you guys a little bit. Is everybody doing okay? Thumbs up. Okay, you guys can hear me. I haven't just been talking to myself for the last 30 minutes. Awesome, perfect. Okay, that's why I wanted to make sure, because I can't see you guys normally when I'm doing this, so I didn't want to. Just want to make sure. All right, let me hide this again. All right, so in this case, we're going to face, right? So we have this 2-inch shell mill, really nice face mill inside the Tontai. So I'm going to select that. And as you see, it's quite big. The speeds and feeds are pretty much all set up for you. You don't need to adjust those too much. We'll leave that. So the next thing to do, stock contours is fine because we're going off the stock. The next tab over here is heights. And so you can kind of see, it gives you kind of a reference to see what we're talking about. You know, your clearance height, feed height, and then it gets really tight in here, but you got your top height and bottom height. So this particular tool, yeah, retract height is the same, I think, as feed height. So for this particular toolpath, don't need to do anything here. If you're drilling or doing some other stuff, there's sometimes stuff you need to do to adjust in here, especially your bottom height. If you're drilling a hole, there'll be another option here of like, they'll have a checkbox of drill tip through bottom, and you'll want to check that, because if you don't, it'll drill until the tip of the drill hits the bottom height, and then it will retract, which obviously if you're trying to drill all the way through is not ideal, because then you'll still have material at the bottom of the hole. But for this particular one, we'll do that. So we go to the next tab is passes. We're really close to the top again. So I'm not going to need to do multiple depths, but if you needed to, you can do multiple depths, and then let the machine know how much to take off at each pass, and it'll do multiple passes. You don't necessarily need to do anything with these, but you can. So if I adjust these, I can do, like, say, if you click in here, you can kind of see what it'll do. So if I wanted to go a little bit, like, say, 1 inch past, I can do that. And then I'll make sure to, like, really clean everything off. Stock to leave, if you want to, if say you want to do a roughing pass and then a finishing pass to get a really nice shine on the part, like almost a mirror finish, you can leave in this particular toolpath that limits you to axial. And other toolpaths, other ones, you can do radial as well, like so the walls or the bottom. And so if you want to leave like 4/1000ths, you can do that, and then you can copy the toolpath and say, and uncheck that box, and it'll just take off that last 4/1000ths, which should give you a really nice finish if you want to do that. So I'm just going to click. Oh, let's see. Let's go to the last one. Linking. Nothing much here to do. Sometimes when you're other toolpaths, you're going to need to go in here, and it'll talk about your lead in, lead out, and how you know, if you're doing like a spiral and to cut out this pocket or something, that will be in this area. So we'll click OK. It'll generate the toolpath. So now what I can do is if I click on it like this, it gives me kind of a preview. If I right click on this, I can go to simulate. And now I see a simulation. And if I want to see what my stock looks like, I'll click on stock. And now if I press play, I can see it do its cut here. And so for this particular toolpath, not too exciting. But simulations are really important. One, you can, there's another way we'll use it when we do chamfering of like edges. Simulations are really critical there, but also it's important to do simulations just to make sure you're not gonna, like, you didn't make a mistake. Really, it is like, does this toolpath make sense? Sometimes it will highlight the tool in red if it actually suspects that it might crash into something, if you told the machine to do something that's not really possible. And so you want to pay attention especially to that, right? So after I have that toolpath, Now my height of like my off is still based off my stock, and even though my stock isn't there, it's still based off that. So that's one of the gotcha points, where, you know, say you face this off and then you're like, oh shoot, I'm late for you know, something, and I have to leave. So then you take your part off the vise, and you're like, oh, I'll just put it on there tomorrow. And so then you come back tomorrow, and, you know, and somebody's messed with the machine or changed some things, and you put your stuff back on the vise. Well, now you don't have a stock, you know, you don't have the top thickness to reference to. So now you have to go back into your toolpaths and readjust your setup to be off the top of the model instead of off your stock, because you've lost your reference point. So be very careful of that, because that, again, that's an area where you might reverse that. You might say, oh, you forget that you have stock and actually base your reference point off your model, and then your machine just dives down directly into the stock, you know, material that it doesn't realize is there. So the machine's going to do exactly what it tells you to do, or what you tell it to do. The machine's going to do exactly what you tell it to do. So it's not a smart machine. So it won't fix your mistakes. And it's a very strong machine too. So things won't stop very easily. I would say that. So hopefully, you know, a tool breaks at the you know, at least if the tool breaks is not a big deal. You know, I'd rather have a tool break than a spindle break or something like that happen. So after we've done that, now I could come in and I could do, say, let's do this face here. Now this one might mess us up a little bit. We're going to see. Let's try this. And then I'm going to change my tool, and let's go back to the library here. Let's use like tool number 1, just a flat 1/4 inch end mill. So we get all in these corners here. So let's see here. Let's go here, and we're going to see if this picks up the right stuff, or does it leave this area blank? Does it actually cut the whole area or not? So I don't need to mess with the tool heights on. It's the selected contour, which is what we selected. But you see how this line is selected. So I think it's not gonna be very good for us here in a second. So it automatically selects stock leave. So I'm gonna go ahead and uncheck that. And then you see the different ramping procedures and stuff like that. So this is going to be a helix lead in, which basically ramps down into the part. And you can also do plunge or pre-drill. Like for this pocket over here, you probably want to take a drill bit and drill into it, and then do a plunge tool path, because that will because it's almost too small for like a helix. But for this particular one, helix is fine. So if I do this, let's see what happens now. If I click on it, see how it kind of leaves all these things like blank, and that's not actually what we want, because now we'll just have this like ridge in here, this like valley in these areas, but then these parts will be filled. So what we actually want is for it to clean out this whole level, and then we'll do another tool path where it goes down. So the fact is, actually, there's multiple ways to do all this stuff, guys. So you don't have to do exactly the way I do it. You can play with these tool paths. Like there's the 2D pocket tool path. There's all these different tool paths. So and there's 3D stuff too. But one way we can try to do that is to actually select all these contours, and let's see what it does with that. So obviously this corner over here is not good. So this one actually looks pretty good. Let me see here. So we probably want to do potentially multiple. Well, actually, it's probably okay not doing multiple heights here. So it's going to spiral down until it gets all the way through, and then it's going to clean out. So obviously we have to fix this corner because that's a sharp corner. It's not going to actually cut that sharp corner. It'll still go and it'll cut up to, you know, this area. So, but it won't There's a helicopter flying over my house saying something. But you gotta love San Jose, right? So anyway, that could actually work. We might not have to do multiple heights on that one. What I was gonna say though. Oh, the one thing is, keep in mind, right, that this isn't actually through, the whole stock material, right? The stock material goes down below. And so we want to cut a little bit past the bottom of the material, past the bottom of the model, or else when you face off the other side, you're going to get like this, you could get like this little thin piece of aluminum that's like basically like aluminum foil. And so if you want to like a clean cut when you face off, you're going to want to go to your heights here. And you want to say bottom offset, like -0.02. And so click OK. And now, after we generate those toolpaths, we go down here. And now we can see that it's cutting a little bit past the bottom of the part, but still, not even close to through the bottom of the material of the stock. So we'll do like that. And so now that actually was nice because that took care of, oh, did I just unselect something? Because now it's not doing the, let's see, did I miss something? Okay. No. Well, maybe that didn't fix it. Funny, huh? So sometimes it's kind of odd like that, where it will like, if I don't select these bottom ones, it cuts out this part. If I select both of them, then it only cuts out the bottom part. So let's try a 2D pocket and let's do the same thing. This one we're gonna do like this. See, so now a pocket, you see it's all in blue. So we'll stay on tool 1 here. And then let's see, stock to leave, let's check that off. And then this is fine. And so now you see it does the pocket. And so we can readjust these toolpaths to say, okay, let's do this one first. Let's drag this one up in the order. It's going to cut in the order of from the top down. So if we drag this one up one, then now it's going to cut out this whole thing, and then now it's going to cut out the bottom pockets. So already we're pretty good. So the next one you can do would be like, you can use either 2D. If we cut out the outside perimeter, you could use a 2D contour probably. If your stock is a little bit bigger, you can use a adaptive. It'll clear out those edges. Let's just go ahead and use a contour. Let's do that. Let's go ahead. We can use the same. We can use a 1/4 inch end mill if we want. We can use something bigger. Is fine. There's a 3/8, I think. Yeah, say 3/8. So, and then this one I probably should adjust the cutting speed a little bit. Cutting feed rate's a little bit high, but I mean, even 80 is fine. It can handle it. Just kind of scary. It's a fast way to cut things. So now let's go ahead, and since we've done all this, normally, actually, I'm going to go ahead and do it. I'm just going to save this. I've known Autodesk Inventor to crash when you do toolpath simulations. So, no, oops, wrong one. It's better to save. So before you run a simulation.